distribution with radicals, and rationalizing with conjugates. This is part 2. We're going to concentrate on the conjugates. Okay, on page 8, rationalizing with conjugates. We're going to put something here in the parentheses, and it's going to come out to a squared minus b squared. So if you remember our factoring, this is the difference of squares. So what will go in parentheses? Well, it's going to be a plus b times a minus b. So anytime you have the same binomial with a different sign in between, it's going to be called a conjugate. Why do we need the conjugates? Well, when we multiply them out, the middle term will always cancel each other out. So take a look at this. A times a gives us a squared. A times b, negative b, gives me negative ab. B times a, positive ab. And b times negative b gives me negative b squared. Well, look at these two. Different signs cancel out. So this is why we get the difference of two squares. The question is, when do I need a conjugate? Well, if there is at least one radical in the denominator and it is added or subtracted with another term. So we should see a radical and we should see a plus or a minus operation, which indicates it's being added or subtracted from another term. So let's check this out. So go ahead and look at all of these terms that I have up here. We're going to put them in categories. Either it needs a conjugate or it doesn't need a conjugate. Okay? So let's take a look at 1 over 3 minus the square root of 2. Well, does it need a conjugate? Of course it does, because it has 1 over 3 minus the square root of 2. So we would put it here in this category as, you need a conjugate, 3 minus the square root of 2. Let's take a look at the next one. 2 minus the square root of 3 over the square root of 5. Well, it's just one term down here, so there's no plus or minus. There's not a binomial in the denominator, so we're going to put that one in the category over here. You don't need a conjugate. 2 minus the square root of 3 over 5. Take a moment to fill in the rest. And so you have 1, 2, 3, 4, 5, 6. Put the other 6 terms inside of these little boxes, and then we're going to check the answers. Alrighty, so take a look at everything that needs a conjugate. We see 2 terms at the bottom, 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 and 1 is a radical. Let's take a look over here. 1 term at the bottom, 1 term at the bottom, 1 term at the bottom, and 1 term at the bottom. Okay. So basically, this one here needs a conjugate. So our note says to multiply the top and the bottom of the fraction by the conjugate of the denominator. Well, we talked about what a conjugate is. A conjugate is going to be the same terms in the binomial, but a different sign. So that one is a subtraction, so this one is going to be an addition. So that's the conjugate. And we're multiplying. So let me go ahead and put the parentheses here. Now the second thing says multiply the fractions top to bottom and bottom to top. And so whatever we do to the numerator, we do it to the denominator. And whatever we do to the denominator, we do it to the numerator. So we're going to multiply the numerator by 2 plus the square root of 7. Next step, we're going to multiply. Well, here, if we do FOIL, we get 2 times 2, which is 4. 2 times the square root of 7 is plus 2 times the square root of 7. Now let's distribute this. 2 times the square root of 7, negative square root of 7, is going to give us negative 2 times the square root of 7. And then when we multiply our back terms, it's going to give us minus the square root of 7 times the square root of 7. Well, take a look at this. This is what conjugates do. They cancel out. Our first term is 4. Our back term, we have a pair. So 4 minus 7. So this is going to be -3 in the denominator. We're not done. We're going to have to multiply the numerator 5 times this expression. So here we go. 5 times 2 gives us 10, and 5 times the square root of 7 gives us 5 times the square root of 7. There's nothing that we can do to break this down any further. We don't have a radical in the denominator anymore, so we have been successful. Yay! Okay, we're going to practice a couple of these. The question is, do we need a conjugate here? Yes, we do. Why? Because there's a binomial in the denominator. So what is the conjugate going to be here? It's going to be the square root of 5, and it's plus 9, so we're going to make this one the conjugate, square root of 5 minus 9. Multiply the top and the bottom by the square root of 5 minus 9. So we're multiplying, so let's just go ahead and put parentheses around everything to show that we're multiplying. The denominator, after we FOIL, we are going to be multiplying the first term, and we're going to be multiplying the second term. On the top, we're going to be doing the distributive property, which is 3 times the square root of 5 minus 27. Let's simplify this. This is 3 times the square root of 5 minus 27 over, we have a pair. This comes out as 5, and 9 times 9 is 81. There we go. 5 minus 81. -76. We can't simplify that anymore. That's the answer to number 2. Check out number 3. What's the conjugate? Square root of 2 and the square root of 5 are the terms. This one has a positive, so what we're going to do, we're going to find the conjugate, subtraction. Multiply the top and the bottom by the same thing. Now we distribute here. Well, we're going to do square root of 2 times the square root of 2. And our back term is going to be square root of 5 times the square root of 5. And that's the denominator. The numerator is going to be the square root of 2 times 2 minus the square root of 2 times 5. Let's simplify. Pair, come out. 2 minus the square root of 10 over 2 minus 5. So at the top, we still have 2 minus the square root of 10, but 2 minus 5 is -3. So here is the final answer. I'll let you try this one, put it in your booklet, and you can show the teacher later.